chemistry, we have come across a few words. And I've also revised yesterday some of the terms that we went through in class. Okay, today, the main focus will be on the last part, mixtures. Okay. So far, we've talked about a few things. First one, elements. Second, compounds. Last but not least, mixtures. Okay. When we look at elements and compounds, one of the things that we learned so far is that they are pure substances. That means to say, you just look at a box of compound or elements, they are pure. If I have this particular particle diagram that shows atoms like that, just one type of atom, that will be element. If I have another box that contains molecules that perhaps looks like that, even though they are chemically combined, if you find that it's the same type of atom in the same box, we can still refer to it as a pure element. If we look at compounds are a little bit different. Let's say I combine these two together and they chemically react with each other. Chemically combine. And maybe I get something that looks like that. As long as you find in the molecule more than one type of atom, you have a compound already. All these diagrams you see here, we refer to them as particle diagrams. We love to ask you to differentiate. And if you can differentiate, then you pick up the skill. We may ask you to draw a particle diagram. That's the reverse way to show your understanding. Okay, so there's a quick recap. So what is a mixture? Well, what if we aren't able to chemically combine these two elements? Let's say it turns out like that. We put the two together, but just like my plate of iron and sulfur that day, they did not chemically combine with each other, I end up with something like that. Okay, as I'm drawing, I'd like you to think. This is a mixture of, okay, what would you say? This is a mixture of, let's say they do not chemically combine with each other. How will we refer to this? Mixture of two elements. Yeah? Mixture of two elements. Let's say I throw one more in the mix. Maybe I throw this fella here and throw it into the box over here. Now, this is a mixture of, thank you. Now it's a mixture of two elements and one compound. Okay? I hope you are able to now see the differences between a compound and elements. If they don't join together, we say it's a mixture of them. Okay? So this is a skill to pick up. Today we're just going to look at, finally, we look at the properties of elements. And what we learned yesterday were that there are different types of elements. There are metals, there are non-metals, and then there are the in-betweens called metalloids. Yesterday we also learned that compounds, other than the fact that they are chemically combined from a few elements, they are also combined in a fixed ratio. And the interesting thing is that when elements, you combine them to form new compounds, somebody else saying something. Thank you. The chemical and physical properties change. Just like how if you combine sodium metal and chlorine gas, which is poisonous, if they are able to chemically combine together to form your table salt, sodium chloride, it's not poisonous. You can eat it in moderation. Today, we're going to look at the properties of mixtures. First, there are many different kinds of mixtures, and actually in your daily life, you have encountered quite a few of them. For example, all of these over here, they are mixtures. You've seen them in your real life before. Sandwich, yeah, that's a mixture. Muddy water, that's a mixture. Hand sanitizer, actually your hand sanitizer is not just composed of one substance. There are many things that go inside. Alcohol, some things that give a nice smell. Air, the air around you is a mixture. Mixture of various different gases. Oxygen, nitrogen, what else is in the air? Oxygen, nitrogen, carbon dioxide. It's a mixture of elements and compounds. Have you heard of the word alloy in primary school? Okay. Some of you have, some of you may not. If you ever see the word alloy, it means to say it's a mixture of metals. For example, steel. Steel is not a compound or an element. You cannot find it anywhere in your periodic table, steel. Because steel is a mixture. It's a mixture of many different metals. I actually forgot what steel is made up of. Oh, you learned before?
I have carbon.
What is steel made up of? Steel mixture. Oh. Steel is a what happened? Steel is a mixture of iron and carbon. Let me change the definition a bit. Not just a mixture of metals, and other elements. For example, steel is made up of iron and carbon, not chemically combined at all. They are just mixed together. You know what that means? If they are just mixed together, it means that they still retain their original properties. That means steel is magnetic because it still carries the property of its iron that was combined with it. Okay? But they are not chemically combined, so they still retain their properties. Okay, so to end off the topic, just going to introduce to you some of the various kinds of mixtures that you have met before. First and foremost, you were asked to do this checkpoint yesterday. How was it? Doable? Okay, at this point in time, if you find it quite doable, then I think you are growing stronger and stronger in your foundation for chemistry. So here you have a compound. May I just get you to refine it, write it a little, give a little bit more detail. Pure compound. Okay, if you did not write the word pure, you write pure compound. Next, this is a mixture of two elements. Next, this is a mixture of one element and one compound. Then we have a pure element. Specifically, they are molecules of an element. Last one, they are a mixture of two elements. One of the elements exists as molecules, the other element exists as atoms. Okay, and so today I'd just like to introduce two terms to you, heterogeneous and homogeneous. The word, actually the front part of the word you will have seen before used in various different contexts. Hetero, homo. Hetero means not same. Not uniform or not the same. Homo, same. So we have two kinds of mixtures that exist. You have either heterogeneous mixtures or homogeneous mixtures. Some of the things that you have around you that exist, they are either one of these two. And I'm going to give you some examples. For example, if you look at sand and water is an example of a heterogeneous mixture. They are not uniform. Have you ever experienced this? If you collect water and sand, you give it a swirl, and then it becomes a cloud, right? A cloud that you cannot see through. After a while, it will settle. This is an example of a heterogeneous mixture. They do not mix in a very constant and uniform way. They are not mixed constantly at all. In fact, you leave it for a while, they'll start to settle and separate. Some examples of mixtures that are homogeneous. Okay, I'm going to go to the next slide. I think this is more relatable to you. Notice that when you try to make sugar and water together, sugar is a compound, water is also a compound. If you mix these two mixtures together, they will mix in a very even way. To the point that actually they don't separate. Right? If you leave a cup of sugar water, it's not like the sugar will sink to the water will split from it. They are mixed very evenly. We refer to those as homogeneous mixtures, and then you have heterogeneous mixtures. Okay, now offhand, I'd like you to think, in your daily life, can you think of some examples of mixtures that you think are homogeneous and some that are heterogeneous? And then we have a talk, right? We see if we, because I haven't thought of all the possible kinds of examples in the world. Any examples you can think of in real life? Yes. Oh, okay. Milk and cereal. Let's look at milk and cereal. Is this a heterogeneous or homogeneous mixture? Homo. Okay. I mean, normally when you eat cereal and milk, the cereal floats to the top one, right? Yeah. So they are not mixed evenly across. So actually, we would consider that a heterogeneous mixture. Okay. So first example, thank you. So this one, hetero. Okay, next, any more examples you can think of? Then we see if it's a hetero or homogeneous. Yes?
Milo powder and water.
Oh, Milo powder and water. Okay, that's an interesting one. Plus water. What do you think? Homogeneous? Heterogeneous? You think it's hetero? Okay, you think it's heterogeneous? Anyone agrees? Okay. So some of you think it's homogeneous? Okay. Why do you think it's homogeneous? Yes. So how? Is this hetero or homo? Okay, thank you. This example is a very interesting and unique example. Because usually it's very straightforward. Sand and water. Okay, I tell you, if I were to teach primary school students these two words, I would categorize it very clearly into two sections. And then usually one of the indicators that something is hetero is that if you leave it to the side, it will eventually separate. Another characteristic of heterogeneous mixtures is that other than it separates, usually when you mix them together, you get a solution that is opaque, that you cannot really see through it. But then Milo. Okay, so the interesting thing about Milo is that Milo consists of many things inside. If I were to split Milo up, there's a lot of things inside, no? Actually Milo has sugar. Milo has Hey, you know the whole recipe in your head?
No, I don't. I'm just guessing.
Okay, cocoa powder, yeah. There's a lot of stuff. There's malt, alright. There's also something called emulsifier.
The Star Wars guy.
Okay. Anything else? Anyone remembers Milo pack? Salt. Okay, salt. I don't know. I'm not sure if it's salt. Okay. So the interesting thing about things like Milo is that actually Milo itself is already a mixture. Yeah. Okay. So the reality is when you mix Milo and water, actually it looks like they stay together, right? Okay. But actually some components mix homogeneously in the water. Some components don't. Some components, you leave it long enough, it will separate out and settle one. Okay, so actually it's a very, very interesting example that has just been brought up. So is this a homogeneous or heterogeneous example? Actually, I didn't put it up here because it is rather complicated. The reality is that things like the sugar would have dissolved in and it would become homogeneous sugar. Things like the cocoa powder, or actually if you leave cocoa powder by itself, have you ever tried to throw cocoa powder in water? It won't stay in, it will float itself. Okay. Actually, inside Milo powder, there's also some what do we call it? There's milk powder inside also called Milo powder. Okay. So if you ever look inside a lot of your drink packets, they actually add a chemical inside that prevents the whole heterogeneous substances from splitting out. If you ever see the word emulsifier inside any one of your drink packets, these emulsifiers are very important. When you add emulsifiers, they help to prevent splitting of the substances and separation. So if you ever drink like a Milo packet, right, you notice that they are quite still evenly mixed. That is the job of emulsifiers, and you find them a lot in your foods. Okay, thank you. Interesting example. Anything else? Everyone have a conversation about? Oh, what about air? Heterogeneous? Homogeneous?
It's mixed, but whether it's like.
Yeah, you want to say something? Okay, what do you think is hetero? Say what? Okay, air could settle itself. Which component of air? I believe you cannot see air also, so I cannot tell if any of the air settles per se. I think it is, yes. Hetero, why do you think it's hetero? Okay, so air is an interesting one again. Let's say in this room right here, actually one may say that it's homogeneous. Because if I were to breathe in this part of the room, then I breathe in that part of the room, roughly the amount of oxygen going in is around the same. But actually if you go to different parts of the world, you go to different altitudes of Earth, right? You climb a mountain, the higher you go, less oxygen also, right? Then you go to different parts of the world, some parts of the world very polluted, right? Lots of carbon dioxide, lots of fumes going into the air. So if you look at it globally, air is also not very homogeneous. It's quite heterogeneous if you look at it globally. Yeah? So what are examples of homogeneous mixtures? You tend to find them in the lab. When we give you some things that can dissolve in water, those tend to be homogeneous. Okay? Sorry? Coffee and milk. Okay, let's look at another example. Coffee and milk. This is again very interesting because actually I ignored milk earlier on. Do you think milk is an element or compound? Compound? Okay, because you don't see milk in everyone's table, right? Right? You don't see like M-I inside. Okay, so what is milk? Yes. Okay, milk actually is a mixture of many, many different things. Milk has water, which is a compound. Milk also has a lot of fats. And there are many different kinds of fats. Each one of them are also compounds. What else do milk have? Milk actually has these things called proteins, which are also compounds. So milk is a mixture of many compounds. Some elements inside also. Coffee, what is coffee? Well, coffee is complicated. Coffee powder is like the seed of a plant, right? If you were to mash up a seed of a plant, actually it contains many things. In fact, it contains a lot of cells. Inside cells, they are made of many things. Lots and lots of different compounds also. So if you mix these two together, I would say it's a kind of the same scenario as Milo powder and water, where some things you mix homogeneously, some things heterogeneously. Yes. Coca-Cola and milk. What about? Okay, I think it falls again into these categories. Okay? I don't know what it is. I don't know what happened to Coca-Cola and milk. I think there'll be a reaction of some sort. Okay. Lastly, today, you may see this other word. Okay, so we have homogeneous, and then you have heterogeneous. Okay, you may sometimes see the word suspension. Have you ever heard of the word suspension? Not suspension bridge, but actually the word suspension also has the same idea here. You are suspending something in something else. Okay? So a suspension is also falls under the category of heterogeneous mixtures. Suspension. Let's spell it the same way. Okay? Suspensions are a type of heterogeneous mixtures. They tend to be opaque in nature. You all know in primary school what opaque means? Okay, opaque means that you cannot see through. So many heterogeneous mixtures are suspensions where the solid is just floating across the liquid. We refer to that as suspensions. For example, sand in water. You swirl sand, the sand is suspended in the water. That is a suspension. It is a heterogeneous mixture. What else could I make into a suspension? So in a sense, Milo and water, it is kind of like a suspension. Some parts of it are suspended. For example, the cocoa powder is suspended throughout the water, that's why it looks completely brown in nature. But the sugar is properly mixed throughout. That is homogeneous in nature. Suspensions are a bit special because if you leave suspensions for a long time, they will separate out. Milo actually is really for a long time, all the cocoa powder eventually will separate out also. That's why people sometimes say, if you want to drink Milo pack, or before you drink it, you give it a shake first before you drink, just to mix the chocolate part throughout. The sugar part actually don't need to shake. The sugar part will always be constantly, homogeneously mixed throughout. Okay, then we are coming to the end of this part. Just like to remind you that when you look at mixtures, all these components do not chemically react with each other. They still have their own property. You can still taste the chocolate. You can still taste the sweetness of the sugar. You can still taste the milky part. Right? They have not mixed together or reacted with each other. Okay, this part is a summary. If you flip to this page, that contains this table. Are you able to fill this in now? If you are able to, then I would say that you broadly understand this topic. This table is a very good example of a summary of this entire topic. How do you know if something has chemically combined or not? That's a good question. Okay, first one, my first reply to you, which will sound very lame, is that experience. Because if you have the experience and you know that these two elements together will definitely react, then you will know that whatever came out is alcohol. Okay, so there are some, maybe I'll let you all complete this first, then I'll answer Megan's question. So the question is, how do you know? this loved one. Yeah, keep that in mind. If I see any books, I recommend to you. Unfixed, unfixed feels like to undo something. Okay, I think better would be to say it's not. I think, yeah, the word un feels like there's a reversing process. Like you undo something. Okay, I'm going to show you now how we fill this in. I acknowledge that some of the words we use here are purely just a choice of English. Yeah, you may use something different. If you would like to double check if your choice of word is still okay, please let me know. So, they are formed through chemical reactions. Okay, I know these two maybe you did not write together. What's an example of a physical reaction? A physical reaction is like maybe just mix them together. Okay? That is an example of physical reaction. A chemical reaction is one where it requires usually heat, electricity, so on and so forth. Oh, Mentos and Coke. If I'm not wrong, that is not a chemical reaction. It's something to do with the Mentos on the surface. If you use a microscope to look at Mentos on the surface, it's not smooth. It has many tiny little holes. And when you put that into Coca-Cola, if I'm not wrong, it causes all the gases inside Coca-Cola to come out from the liquid. I don't think it's a chemical reaction per se. Okay, next, the property of elements is fixed. The proportion of the elements is fixed. Some of you may have put fixed ratio. Proportion of each component can vary. Or other than vary, you put not the same, not constant, same idea. Next, chemical and physical properties are different from the, you see this word constituent. Constituent means the elements that it is made up of. That's what I mean, constituent. Chemical properties are similar. Last but not least, elements and compounds. Elements and compounds, they are both pure. Pure substances should have fixed melting and boiling points. Yeah? For example, the water that you know of, if it is pure, it should always boil 100, melt at 0 degrees Celsius, and freeze at 0 degrees Celsius. But if it is a mixture, you'll find that there are very boiling and melting points. Go and try. Go and try to boil your Milo. Okay? Go and try to boil your Milo. Every pack you'll get a slightly different boiling point. So try to look at me on it's like, what in the world boils Milo? Hey! Can you freeze Milo? Cannot. Ice cold Milo.
My brother put Milo into an ice cream mold once and it was quite
Oh, okay. I remember last time when I tried to make a Milo popsicle stick, right? I'm very happy, you know. I go and fill it up, fill like the container in Milo, then I put the stick in. Then when I took it out, right? What happened? No. So my Milo stick, when it came out of the popsicle, the chocolate part was over here. Then here came all the water part. Yeah. Oh, ice cream. That's a fast way to ice cream. Sorry, yes? Or Milo. I don't know, Ethan. It will vary. It varies. Depending on how much Milo you put inside the water also can vary. Yes, it's Milo ice cream. So, I tell you you see if you look at Milo, actually the reason why you can even make things like Milo ice cream is because again it goes down to this. You don't believe I go and look in a lot of the food packets, food drinks, ice cream especially, you'll see this one emulsifier. The role of an emulsifier is to help keep the mixture that would have been heterogeneous. It keeps all the components within the liquid. Yeah, so that's the beauty of emulsifiers. You cannot do without it. Okay? To end of this chapter, you look at this Venn diagram. Venn diagrams, you like draw Venn diagrams because where they intersect, that's where similarities are. So what are some similarities and differences between elements, compounds, and mixtures? What did I do? Okay, you could use this as a summary page for yourself. What are some similarities between elements and mixtures? What are some similarities between elements and compounds?
You all have elements.
Which one all has elements? Yeah, okay, so you can see there are some overlaps here and there. For example, if we look at elements and compounds, what may be the similarity between both of them? Actually, both of them, they are made of atoms. Yeah, so there are some similarities and differences. This I'll leave to you. I will not check, will not go through, but you can use that as a reflection for yourself or to note down some similarities and differences. Okay, today the remaining time, let's do some of your homework class. Okay, I would like to run through what all these questions inside your worksheet are about. Okay, take out your worksheet. If you did not bring a worksheet, it's okay. I'm not going to scold you. Yeah, I did not tell you to bring a worksheet anyway. But now that we have time, for those that brought, you can start doing already. I noticed ever since all of the boys speak up, the class has been a little bit more quieter. No, from my years of teaching, my experience is that girls are a little bit more focused. They're quiet in class. They're good at what? Hey, that's an interesting perspective I've never heard before. Girls are just better at hiding. Hiding what? Watch your words, Your class got a lot more girls than boys. Don't want to make enemies. Okay. Question 1. I'm going to tell you what question 1 is about so that you can do it. Question 1 wants you to read through all of these sentences and they want you to pick out which one of the components inside the sentence are elements, compounds, or mixtures. So let me run through the first example. Let's read the first sentence. Water is made up of hydrogen and oxygen. From all of these words here, can you tell which one are elements, which are compounds, which are mixtures? Okay? Okay, then you just write it out in the boxes. So for example, which one of these are elements? Hydrogen and oxygen. Are there compounds here? Yeah. There is water. Is there any mixture mentioned here? Don't have. They just put nil. Don't have. So you read through the other sentences, try to figure out which one are elements, compounds, and mixtures. Page 2. Let's flip to page 2. On page 2, question 2 are questions you've done before. Particle diagram. Okay, page 3. This question wants you to try to find out which one are likely metals, non-metals. These are the properties. Page 4 wants you to figure out this puzzle. Figure out whether this is a pure substance or mixture. Last question 5 deals with today. Want you to figure out whether it's homogeneous or heterogeneous mixture when you mix them together. Before you begin, let me answer a curious question by Megan. She asked, how do you tell if you form a compound or not? Let's say you mix two things together. How do you tell if they are just at the end of the day a mixture or a compound? Like we mix Milo and water together. How are you sure that that is still a mixture and that you didn't form something totally new? Okay, in chemistry, we will teach you a few years, next year. How do you tell if a compound has been formed? There are really a few telltale signs. Number 1, color change. Normally, if a reaction occurs, you'll find that there's a color change. Next, sometimes,
Because I want to throw away the paper.
if a compound is formed, there will be a change in temperature. Some reactions that you carry out, the reaction are, for example, if you mix a metal and water together, sometimes the whole water, the beaker, will turn very hot. Okay, so sometimes temperature change is a sign that a chemical reaction has occurred. Last but not least, you can tell by whether it still has its original physical and chemical properties. For example, I know that Milo has not formed anything new because when I mix the Milo powder and water together, it still has all its original properties. It still is liquid like the water. It still tastes like the cocoa powder. It still tastes like the milk. It also still tastes like the sugar, the sweetness of it. So no reaction has occurred. Okay, but in chemistry, as you progress through the years, I find color change and temperature change a good sign. Sometimes you may smell something different. Okay, that may be a sign for you. Okay, so in the remaining time, you can begin on your homework. If you have any questions for me, you don't know how to do any part of your worksheet, you can raise your hand and come to you.
Usually, they write it out where the elements are synthesized. Usually it's
So mixtures, right? They don't have a name. If I mix Milo powder and water, it's still Milo powder. Yeah. So mixtures don't really have a name. Oh. So you can put it under the best option. Okay, right. Right. This is impossible to do. Okay, then don't put anywhere. It doesn't fit the bill anyway. Oh, no, it's a sugar. Glucose and sugar. This one, I have to say, ask me to. I'll come back to you. Try it. Okay. I mean, you see hydrogen gas, right? So it's hydrogen gas and element compound mixture. Oh, they're not asking for anything. They are just giving you a sentence describing something that happened. And they want you just like that. Oh, you don't have a worksheet today? Sorry? Oh, what the? Okay. Let me see. Why are you so fast? You did at home, is it? Oh. Wow. I need your help, Your handwriting needs to be a bit better.
Yeah, lor, yes.
Brian was. Yours is not any better, like, it's so much. Okay, yours.
Yeah, it's not expensive. See, it's got more time.
Okay. It will help if you want to keep your style of writing right quicker. Then it will be easier for you.
Hello, Brian.
Yours should just fight. Oh, go outside, pick it up.
Why not there? I have to walk to get outside.
Okay, if something is really combined with your format,
What number of yours?
No, you said Mercury is the number.
then the last way, just as we learned, compound should have the same property. So the properties that you improve the pH. And if you want property, test the pH volume of for example, you take oxygen and carbon gas, the boiling point of the properties that the oxygen.
You guys should be not acting can use different.
Supposing the result goes, what would you do? Supposing the result state this, what would you do? How would you use the result? Decide whether it's a bias or Good.
Good. He's not good. You literally made me lose some pencil.
Are you gonna melt it and resell it?
Yeah, you should have melted it.
How about the one that melt the
Oh, you know, the camera thing.
Oh, I found that.
Yeah.
Oh, I see that hair.
What's that email? Oh, you done? Oh, okay.
But what is it?
Oh, no.
But what is it?
Okay.
I don't know. All the.
The content mixture.
Mixture, obviously.
I know that. I don't think.
Well, then you go.
In P6, I haven't done that. No, I didn't take like a bunch of untapped papers.
Oh, yeah.
I didn't take the intro in class. You have the specimen there.
So, right, so then you went the outfit.
What's the name?
Do I want to check out the program? But why?
You put other things under the list.
Actually, it's like this. It's unresponsive. And don't do it fast. I know it's very expensive, but it's gonna make you pay. I just told you.
How did that go? You want it? Usually can tell if something is wrong. Two elements. Oh, okay. The 2v1. Come on. Using child scissors.
You come up, give it, you know, you're gonna use it, but you can see that from
When we write
And then,
side by side things can
and then using this example, I guess the way not to see you, so then stitches. You didn't lock it,
How does it unlock it?
it auto locked.
Oh, then I know how to use the.
And I really don't
Why
care.
not?
It's made to cut knots.
And go. How did you fail twice?
It's made to cut knots. What then
That quite about it. You study so you study a computer.
Oh yeah, I want to see. Sure, it's happening. Hold it down here.
Okay. My poor drama.
So you can go for 2 Chinese food. 4, 6 years.
What am I gonna do?
I don't know.
You can do that.
Electrical school is a very young age. Then you went from this school.
You want to try?
Nope.
Now sell all class C, but they're on the stage.
Oh, cut it out.
I'm a
Throw it faster. Too far.